Hello dear GATE aspirants, welcome to VEDA GATE Academy. In the previous discussion, we are partially done with the classification of control systems. One of the main important classification what we are left with is open loop and closed loop control system. Our heading is open loop and closed loop control system. For understanding this open loop and closed loop control system, let's take the design of elevator or lift. Elevator is also called as a lift. I think all of you might experience how elevator works. Let's do our design. Imagine we are the first person to design the elevator. In the last stages, we will compare with the practical elevator. Up to that, please do not compare our design elevator with the practical elevator because we are in the initial designing stage. A lot of difficulties we are going to get. Let's see. Design means do not think that we are going to connect a motor rating or electronic circuits, control, all what do you call the microcontrollers, all those things we are going to use. No, please. Only logical way of analysis we are going to do here. Logical way of analysis. Come on. Here, for elevator to work, definitely we need a motor. Yes, why? Because when motor rotates, then only the elevator moves either up or down. But we want that action to be a controlled action. Therefore, definitely we need a controller. Yes, sir. Let's take fan as an example. I'll explain first, then we go to the elevator. We have a fan here. We have a fan. Come on, this is a fan. Yes, fan. Now, to this fan, can I give directly 230 volts? 230 volts AC supply. Our household supply in India, 230 volts AC, 50 hertz. Can I give directly this supply to the fan? If I give directly this supply to the fan will rotate at its full speed. Yes, then it's no more a control system, just it is a system. So I want to control the speed of the fan. For that purpose, I am taking speed regulator. Now I want the sequence of connection. Input is given to fan to regulator is the first choice. Second choice is connect this input to the regulator, connect the output of the regulator to the fan, which is correct. Second one is correct. Come on here. Here we are going to keep a regulator. Input is given to regulator. Yes, this is a regulator. Output of the regulator is connected to fan. Yes. If not, if you do in reverse way, total input if you are connected to the fan will rotate at its full speed, and there is no use of connection of regulator to the fan after that. Okay. Now here 230 volts. We know general regulators are going to have total 5 positions. 0, 1, 2, 3, 4, 5. Total 6 positions if you take 0 also into consideration. If the knob of the regulator you are keeping at 5th position, total 230 volts is given to the fan will rotate at its full speed. Yes. If the knob is in 4th position, some part of the input has been cut down. Input to the fan is less, therefore the speed of the fan will reduce. In this way, we are going to control the speed of the fan. The sequence of connection, why we taken this example is the sequence of connection is input. This regulator is called as controller. Yes, this is controlling the input, therefore it is controlling the speed of the fan. Yes. Fan is called as system. Yes, fan is a system. Yes, this is called as what? Controller. Regulator is called as controller. Come on, brother. Very simple analysis. This one we are going to extend towards our open loop and closed loop control system discussion, and we are going to do the design of elevator. Now tell me, the output of the controller is called as what? This is called as a control signal. What is that? Control signal means a controlled version of input signal. We are giving input here. In that, some part only we are going to get as a control signal. That work is done by this controller. Sometimes if you keep in 5th position, total input may come. That is not an issue. Okay, but we have that option to control the input signal so that our output of the system here, output Output is also called as actual response or response. What is that here? Speed. N denotes speed. Okay. This output is getting controlled with help of this controller. The sequence of connection is input, controller, output. Yes, output of the controller is called as what? Control signal. Control signal. This is very important to understand. Okay, let's go for our practical design of lift. Yes, a lift definitely require, lift or elevator require a motor. We call that one as system. We call that one as a system. Yes, I'm taking a system here. Yes, I'm taking a system here. Come on, this is what? System. Yes. To the system, if I give directly input, the motor of the elevator always keep running. What happens? The lift keep on moving either up or down. It's keep on moving. It's not a controlled action. We want the lift to move for some time. After that, it has to stop. Yes or not? Or whenever the desired floor comes, it has to stop. Again, it has to move. Uncontrolled, if it is moving, what happens? It may hit the ground or it may hit the floor. Yes. Therefore, definitely we need a controller. We need a controller. Where the position of the controller? Before the system or after the system? Before the system. Yes. This is, yes, controller. This is controller. Come on, ma. Understand carefully, brother. This is controller. Yes, controller is connected to system. Here, what this side is given? Yes, input is given this side. Yes, this is the input signal. Input signal. What we are going to get here? Output. What we are going to get here? Output or actual output. In fact, the output of this controller is called as what? Control signal. Very, very important. Control signal. Yes, we have input, we have controller, we have system, and we got the output. This is a sequence of connection. Does we taken any feedback here? I am introducing a new term here, that is feedback. Sir, what does it mean by feedback? What is the use of feedback? What kind of feedbacks we have? We are going to see all these things. We are going to see carefully. We are going to see. Before I proceed, here I want to explain few things. That is, every control system is going to have two parts. In fact, one is means two inputs. I can say not exactly two inputs. Two parts I can say. One is a signal part. Another one is a power part. What is that signal part and power part? See here. If you enter into a lift, what is the input you are going to give? Input to which floor you want to go. That input you are going to give. Suppose if you want to go to 4th floor, you are going to press the button 4. That's it. Yes or not? Come on, brother. Very simple. If you want to go to 5th floor, what you press? 5th floor button you are going to press. Means you are here. If you press, yes, come on. Let's take here. If you press 5 here, yes. If you press 5 here, that 5 is a signal input, but not the power input. Signal input. See, every control system is going to have two parts: signal circuit and power circuit. What is a power circuit? For this motor to run, huge amount of power supply with a large amount of voltage, 230 volts or sometimes 440 volts. If it is a three-phase motor, 440 volts is required. So it is having another part which we are not showing here. Power circuit part is there. Please do not forget about that. It's very important. Power circuit is completely different. We are not discussing about that. We are discussing only what you call signal part. Very small amount of voltage, very small signal we are giving. That signal will get amplified, and this power circuit is going to give the power to the system. Then system will work. Means this is a lift. Lift required, yes, lift required 230 volts. That this is not the 230 volts, please. Here we are not giving 230 volts or 440 volts. That circuit is completely different here. That will be there here or here somewhere. We are not showing that. If you press button 5 here, a signal command will go to controller. Controller will give control signal. That control signal will control the power circuit. According to that, power input will go to the system. System will run. We are not showing the power circuit part here. We are not showing the power circuit part here. For example, for easy people to understand simply, this is an operational amplifier. Yes, here we are giving this is an inverting amplifier. Yes or not? Yes. Here we are taking ground 0 volts as reference. Here this is also 0 volt. Here I am giving VA as input. Many people don't know the difference between power circuit part and the signal part. I can say very simply, this is the signal part. This is minus 15 volts. This is plus 15 volts. This is the power circuit part. Yes, power supply should be there to the op amp. Otherwise, this op amp will not work. Some people will understand only this. VI is going to work on it. VI will decide how much voltage we are going to get depending on these voltages, plus 15 and minus 15. Yes or not? Without this minus 15 and plus 15, this operational amplifier will not work. So I see we will not show in what you called in our circuits. Most of the times we will not show these things. Just and I'll connect like this. I'll connect one more resistor here. I'll connect one more resistor here. I'll say this is R1, this is R2, and I call this one as V0. If I ask you what is V0, what will you say? Minus R2 by R1 into VI, you say. Yes, this is a perfectly correct part. For this operational amplifier to work, to get this much of output, if input is given, definitely we need power supply that is minus 15 or plus 15. For example, I'm showing here. Yes or not? Yes, this is a supply circuit or power circuit part. In the same way, yes, come on here. This is a signal part. Yes, just if you enter into lift, you are going to press the button 5. Just you are giving a small signal. But who is taking care of that movement of the lift? Power circuit which is present, which is connected to the system, is going to take care. How much power supply has to come, at what speed it has to rotate or it has to move. All these things are decided by the signal command what you are giving. So please do understand that we are giving only signal input or input command. Depending on that magnitude of the command and all these things, power circuit will take care. We are not showing power circuit part here. Come on here. Here we take an input, controller, system, output. Output of the controller is called as control signal. Yeah, I want to go to 5th floor. Which button we pressed? 5. Which button we pressed? Imagine initially the elevator is at ground floor. Yes, initially where it is? At ground floor. Fine, no problem. After some time, it moves to which floor? 1st floor. Yes. After some time, it moves to which floor? 2nd floor. After some time, to 3rd floor. After some time, 4th floor. After some time, 5th floor. Does the elevator will stop here at 5th floor? Yeah, according to you, it will stop in 5th floor. Why? Sir, we given 5. Our requirement is go to 5. Therefore, it reaches to 5th floor. Why it will not stop? For stopping, there should be some mechanism or some signal. Are you giving any stop signal by standing here? No. You are expecting only to give the input at the starting, but you don't want to give a signal when it has to stop. Yes, while you are at a 5th floor, suddenly you are pressing stop button in the practical lift. No, we are not pressing, but it is stopping. Let's see whether it is going to stop here. Our design of this design of lift is going to stop at 5th floor or not. If stops, how? If not, why? Let's see. Now here 5 is the input present here. What is the control signal? Control signal here, very important point here. I'm writing control signal here. Control signal here is a function of input. Yes. What is the input we given? 5. Signal command signal, a small signal, electronic signal we given. So that is 5. That is once you press, that is present or absent, it is present. Yes, that signal is present. It reaches to 0. Does the signal magnitude, input signal magnitude reduce? No. It reaches to 1. That not reduced. That 5 remains as 5. It reaches to 5. Then how does this system knows to stop at 5? No mechanism here. Come on. When this system will understand it has to stop at 5, see, output of the system will be 0 if the control signal is 0. Yes. See, output. See, what is the input to this system? control signal. What is the input to this controller? Input. See, if this is absent, if this is 0, then control signal will be 0. If control signal is 0, then output is going to stop once it reaches to 5th floor. But whether it is in 5th floor or 6th floor or 7th floor, whatever will be the number of the floor, this 5 is present. Why? Because you are not pressing any button to stop the flow lift. Yes, you are not pressing any stop button. It is 5. It is 5. Yes or not? Now it is always present until and unless you are going to stop it. It is present. Once it is present, control signal is present. Once control signal is present, output is also always present. It will go to 6th floor, 7th floor, whatnot. It is going to reach to all the floors. After some time, it will shoot the building. Yes, 6, 7, and so on. After some time, it is going to shoot the roof of the building, which will damage the building as well as life also. Yes or not? Those who are there in the lift will definitely get injuries, or sometimes lot many things will happen. Yes or not? Does this is the correct way of designing elevator? No. What that is missing in this, what that is missing in this is, see, to which floor it has to go, we given the input, but whether it is reached that floor or not, if reached, output of the controller should be 0 and input to the system must be 0, then it is going to stop. Yes, what is missing here? It is feedback is missing. Feedback is missing. What is feedback? We'll understand carefully. We are at the very starting. This design of lift or elevator is not correct. If you design like this, I told you it is going to shoot the building. Why, sir? Until input is present, control signal is keep on coming. Control signal is present, output is keep on coming. Therefore, lift will never stop. What is missing here? Whether that lift reached to the desired floor, what is the desired floor 5 or not, is missing. If reaches to the desired floor, we want the control signal to be 0 and output to be 0. That mechanism is absent. So what to do that? Same system I'm taking, same system what we taken. A small modification I'm going to do. See here, we know input is also called as what, ma? Desired output. Yes, this terminology is very, very important. I told you, desired output. What is our desired output here? 5 to 5th floor. You want to move to 5th floor. Let's take the same thing and make some few small modifications. Let's see whether that is going to work out or not. Yes, I'm taking the same. System is same, controller is same, everything is same. A small modification I'm going to do. Yes, this is the system. Yes, and let's take a controller here. And this is the input. Come on here. Yeah, come on. This is the input or desired output. Yes, we wrote here. Look at desired output, input, or again I'm writing. It's very important. Desired output. Yes, this is what, ma? Controller. Yes, what is this, ma? This is what? System. What is this? Output. What is this? Output. Come on. Now, what is the input to the system? Input to the system is a signal. What signal? Electrical signal. Yes, we given 5 as input. Yes, input is equal to, I'm writing here, input is equal to 5. Some output we are getting. What I'll do is, I'll take the output. How to take the output? So this is called as a takeoff point. The dot what I'm representing, yes, the dot what I'm representing there is called as what? A takeoff point. What does it mean by the takeoff point? Where we are taking the output. Immediately, a student will get a question, sir, how to take the output? What is the purpose of taking the output? taking the output means we are not taking the mechanical output, just we are taking its value, we are measuring its value. What is the purpose of that one, sir? To compare the input and output, or desired output and actual output. Let me write here actual output. This is, what is this, ma? This is the actual output. If I compare the desired output and the actual output, I will be able to know the difference. Then if the difference is 0, the lift will stop. If there is the difference, lift will move further. Yeah, let's complete it. Let's complete it. I'm taking the output here. Then what I'm going to get here, that is also actual output. Only value we are taking. Yeah, for example, there is a motor rotating here. There is a motor rotating here. Motor. This is the shaft of the motor. I think all of you might measure the speed of the motor by using a tachometer. I think both the EC and EEE people learn in your laboratories. The equipment that is used to measure the speed of a motor is called as tachometer. If you put a tachometer here, the reading of tachometer is suppose a 500 RPM. We are measuring that set. If you want, you can take that value. What will you do by taking the speed? Will you take the speed from that? No. Here, what happens? Lift is moving either up or down. Taking the output means you are taking the output like a movement of the lift. How it is possible to take the output? Is it possible to take the output? No. Just we are measuring. That measured value we are taking here. Come on, understand carefully. Lift movement is mechanical movement up and down. Is it possible to take some part of the output? No. Just we are measuring at which floor the lift is present. Suppose if it is in 4th floor, what is this? This is also 4. This is also 4. Yes or not? Now we are taking the output and we are comparing with the input. Some people will understand like this. Our feedback means we are taking the output and we are giving to the input. What input will do, brother? Input is what do you call electrical, output is mechanical. Yes or not? And one more, output is mechanical movement of the lift. Is it possible to take some part of the mechanical movement? No, it is not possible. Just we are measuring at which floor the lift is present, and comparing that one with the desired floor, Yeah, that's why what I'm doing. I'm taking this one to back to input. This point is called as takeoff point. What is that, ma? Takeoff point. Takeoff point is a point where you are taking the signal magnitude, signal value, not magnitude, please. Signal value you are taking. That's it. Suppose if it is 5, yes, this value is also 5. Come on. Now here, suppose if output is in one format, input is in another format, is it possible to compare? See, output is mechanical movement, input is electrical. Convert this mechanical movement into electrical signal. By using what we are able to convert electrical to mechanical or mechanical to electrical? Transducer. Yes, we are going to keep a transducer here. Yes, what we're keeping here? A transducer. So suppose if input is electrical, output is also electrical, need not to have any transducer. So what if we are not having anything means it is 1 direct signal value we are going to get. Now what we are doing here? Now come on, this is actual output. This is also what? This signal is also what? Actual output. Let me write. This is also actual output. Actual. Yes, come on here. Very, very important. Lot of doubts will be clarified with this example. Okay. Now what is this? This is also actual output, brother. This is also actual output. Why? We are just taking the value, not the what you call the see, we are not taking the output, means mechanical movement. Suppose it is going to 4th floor. In that 1 floor I will take, sir. No such type of possibilities are not there. That is not the correct way of thinking. Okay. Just if it is at 5th floor, you measure or somebody else measure, the number is 5 only. That's why this is actual output, that is also actual output, this is also actual output value. For this I'll give some justification. There is a motor rotating with 500 RPM. You are measuring with your tachometer one reading, another with other, your friend is also measuring with second person. third person is also measuring, fourth person is also measuring. Assume that this is shaft of the motor, this is shaft of the motor, rotating part of the motor. Some 100 people will measure. What is the output? 500 rpm only. Yes or not? N number of people are measuring the same, what you call at a time, the speed of the motor. All readings will be same. That is 500, 500, 500. In the same way, here the output is suppose a fifth floor. Either you measure or somebody else measure. Yes, either you measure or somebody else measure. It is 5 only. It is 5. Yes or not? This is 5. This is 5. This is 5. This is also 5. Or you take another takeoff also. Taking off value from a point is called as takeoff point. That will be actual output only. That actual output, if it is in the required format as out of input, then no transducer required here. If it is in different format, we need a transducer. As we take a lift or elevator here, that is a mechanical output, we'll convert that into electrical signal. Therefore, comparison is possible. What is the purpose of comparison? Let us see. What is the purpose of comparison? What device that is used to compare? Comparator. Yes, in electronics, you might design a comparator. Yes or not? Yes. Comparison means what? Subtracting or adding, subtraction. Yes. 4, if you compare with 2, the difference is how much? 2. Comparing means what? The difference, subtraction. Okay. Now I want to compare these two. What are these two? Those two are input, or I won't call this as input now. I'll call this as a desired output. I will compare my desired output with actual output. The difference is called as error. Yes or not? I want to go to 5th floor, but I am at first floor. My desire is 5, but I am at first floor. What is the error? 4. Error is what, ma? 4. Let's compare. Now, for the purpose of comparison, we are taking a device called comparator. In control systems, we call that one as simply a summing point, or summing junction. In control systems, we are calling, or you can call comparator also. No issues. Let me write input or desired output here. Come on, brother. Very simple to understand. Yes, sir. This is input or desired output. Now let me connect this one here. Yes. This is the input, and this is the desired. This is the desired output. This is the actual output. This is what converted form of actual output. If there is a requirement of conversion, otherwise no transducer. It is exactly same, actual output and actual output. This is the converted form of output. Output of a transducer is what? Converted form of output in input format, so that comparison is possible. Comparison means what, ma? It is subtraction. That's why here plus we keep, here minus we keep. Some people will think a lot about this summing junction in the later stages, which is not required, I'm telling. Okay, what this summing junction will do? Simply it will give the addition of all the inputs it is having. Let's write its name. Yes, come on. This is called as what, ma? Summing point. Yes, summing point of, it is also called as what, ma? Comparator. Now the output of that summing point, what we are going to get? Yes, this is the output of the summing point. That is the difference between desired output and actual output. We call that as error. Or let's write it completely, error. Let's mark it and write here, that is error. Yes. Now let's see whether our lift will stop at the desired floor, 5th floor, or not. After completion of that, again we'll see all these terms again. Okay, come on here, all of you, understand carefully. Here the input what we are going to give is 5. The input what we are going to give is how much, ma? 5. 5th floor is the input given. We call input is or desired output is 5. Let me take a different color so that It is easy for us to recognize. Yes. Yeah. 5 is the input given. What is the desired output? 5. Now at present, the lift is at the ground floor. If this is 0, what is this? This is also 0. What is this? This is also 0. Yes or not? I told you very clearly, just it is taking the value. If that is 0, what is this? This is also 0. Come on. What is the output of this comparator or summing point? I told you very simply, just close your eyes and blindly you can tell output of the comparator is a summation of all the inputs what it is having. It is having how many inputs? 2 inputs. One input is 5, another input is 0. How much is 5 minus 0? 5. Yes. Now this control signal, yes, control signal. Let me write here. This is called as what, ma? Control signal. Yes, what is that? Control signal. Control signal magnitude depends on 5, not on input. Please, here control signal, I am writing very important thing. Control signal is a function of yes, desired output minus, come on ma, actual output, or simply I call it is a function of what? Error. It is a function of error. Yes or not? Yes, that is called as error. How much is error now? Error is 5. People will misunderstand like this. Sir, error means that is a disadvantage for us. No. Here, error is the one which is making the lift to move. Yes or not? If error is there, lift will move. If error is equal to 0, lift will stop. If error is equal to 0 means we already reached the target. Once we reach the target, it is not required to move. Yes or not? Come on. Here, input is 5. Output is 0. What is the error? 5. Control signal value is high. Why? Because more is the error. If more is the control signal, happily the system will move. Now, this system reached to which floor, ma? Imagine it reached to first floor. Yes, it reached to first floor. This is 1. This is 1. This is also 1. Yes or not? If that is 1, yes, if you convert first floor, mechanically it measures as first floor. When you convert into electrical, yes sir, this is 1. This is 1, electrical 1. Yes, input is also electrical signal command or command signal. Yes. Now what is this? Error will become, this is 5. What is this? 1. Yes, input is 5. Input is fixed. Desired output is given as input, that is 5. But now the output is increased. 5 minus 1 is how much? 4. This is 4. Error is reduced. The control signal depends on the error. Therefore, system will move further. Why? Because control signal is present or not? Yes, control signal is present. Why? Because error is present. Depending on the error, control signal is present. Yes, if when the control signal will be 0. If error is 0, then control signal will be 0. Otherwise, control signal is present. Some magnitude of control signal is present. That control signal will move the lift further. Imagine it reached to, yes, it reached to second floor. This is 2. This is also 2. This is also, yes, this is also 2. Now, this is also 2, please. This is also 2. Yes, it reached to second floor. What is this will be? 3. Error is reduced. But error is present. Yes, it is reduced but not 0. Error is present. Control signal is present. That control signal is going to move the system. Yes or not? Imagine it reached to third floor. This is 3. This is also 3. Yes. Come on, this is also 3. Yes or not? Yes. Now how much will be the error? This is also 3. Error is 2. Yes. Control signal is reduced. Why? Because error is less. But control signal is present. Lift will move further. Imagine it reached to 4th floor. Yes. It reached to 4th floor. Which floor, ma? 4th floor. Now it is in 4th floor. Yes. 4. This is also 4. Come on, ma. This is also 4. This is also 4. Yes. Now this is also 4. How much is the error? Error is 1. Control signal is further reduced as error is reduced, but control signal is present. Lift will move. Imagine it reached to 5th floor. Yes, it reached to 5th floor. Yes, 5. This is 5. This is also 5. This is also 5. How much this is? This will be, this is also 5. Yes, this is also 5. Come on. Then how much is this? This is a 0. What is 0? Error is 0. If error is 0, control signal is a function of 0. What is that? 0. Or instead of function of, I'll write like this. That is a better way of understanding. Control signal is directly proportional to error. Directly proportional to error. Let me remove here also. Or control signal is directly proportional to error. If error is equal to 0, how much is control signal? 0. Control signal is 0. If control signal is 0, does the lift will move further? No, lift will stop. Did you press any stop button here? No. How the lift has stopped? Lift has stopped. Why? Because control signal is 0. Why the control signal is 0? Why? Because input to the control signal error is 0. Yes, this is the advantage of taking the feedback. Feeding back the output is called as feedback. We are not taking actual output, just we are taking the value of the output for the purpose of comparison. That you need to understand well. So this is an example for closed loop control system. The previous one what we taken is an example for open loop control system, where the accuracy is high, means where we are actually reaching the desired floor in the closed loop control system. Exactly, it will stop in 5th floor. It is not going to move to 4th, what you call 6th floor. It is not going to be stopped at 4th floor. Why? Because yes, why? Because its movement depends on the error. Until error becomes 0, lift keeps moving. Once the error becomes 0, the lift will stop. Which design is a superior design? Closed loop control system design is a superior design. Yes, when compared to open loop system, where the accuracy is high. Accuracy is high in where closed loop control system, it is very less accurate. It is very less accurate. Yes or not? Here, please do not misunderstand about this error. This error is required for me. If this error is there, then only my system will work here. When we have to measure the error, yeah, you have to measure the error once it reaches to steady state. Sir, what does it mean by steady state? You are in lift, you press button 5. Immediately you call that my lift didn't reach my required floor, this lift is not working properly. No, you have to wait for some time. Once the lift starts, it will make movement. It will stop at your floor. If there is some error in that, means yeah, this is the 5th floor. This is the 5th floor. Slightly down the lift has been stopped. Slightly some centimeters down it has stopped. At that point you can say that it is having error. Means it is stopped. The lift is stopped means it reaches to steady state. Steady state means final state. Means yes, you pressed 5. Somewhat a small difference between the 5th floor and where it is stopped, then that is called as steady state error. After reaching to steady state, there is some error. That is a drawback for us. That is a drawback. This is the 5th floor. This is somewhat small down or up. It may stop. You might see in all of you. So that is a drawback for us. But this error, what we have here, that is required for me. Why? Because if this is there, then only my elevator or lift will move. You will understand carefully all these things in where a dedicated chapter, third chapter, that is time response analysis. And in that we have a topic called steady state error and steady state error. So error means the difference between desired output and actual output. See, the difference between desired output and actual output is reducing. Finally, then I can say that that is a system which is required for me. Yes, initially definitely error will be there. This error only making your system to move. But finally, once the lift stops at 5th floor, that is exactly stopping at 5th floor, then we can say that steady state error is 0. We are concentrating mostly on steady state error. Very simple example I'll take, brother. One of the very simplest example. You are preparing for the exam. Final examination is in the month of March, suppose say. You started your preparation in the month of June. In June, you wrote an exam, mock exam. You got 10 marks less compared to 100, means you got 90 marks. You should not feel about that. Why? Because you have further time. Your examination is in the month of March. March month result. See, you are writing exam in the March. So that result you have to consider. Remaining all the results are for your corrections, please. So steady state result is a final result. All the remaining are mock exams. In the same way, this error will be there initially. Our system is making effort to make that error 0. Finally, when it stops, it is not making further effort. At that point of time, you are measuring error, that is called as steady state error, means reaching to final state. I told you, steady state value or final value both are same. That error should not be there. That error should not be there. We will make efforts to make steady state error equal to 0. This error will be there anyhow, not a matter for us here. So this is the difference between closed loop control system and open loop control system. Yeah. What is the difference between these two? What is the difference between these two? Closed loop control system. In closed loop control system, we are taking the output and we are measuring that actual output with the desired output. We are getting that some error. Control signal is produced depending on the error or depending on the difference between desired output and actual output. See, simply take the human brain as an example. You want to touch some object. What will you do? You go there. You move further. Yes, you move forward. You will see the difference. If there is further difference, you will move further. If there is no difference, yes sir, you stop there. There is some object at some distance to you. You want to touch that object. What will you do? You start moving. You take some few steps forward. Just you will measure. Still further the distance is there to move. You will move. Otherwise, you touch it. Yes or not? Once you touch, you are going to stop there. Means that one I am going to explain with this one. Yeah, you want to move 5 meters. Yes or not? Now, here, your brain is a controller. Your brain is giving signal to the body. Your body is moving. Your output is at 1 meter. Then how many meters further you have to move? 4 meters. But how you are able to tell that 4 meters? Your brain is acting like a comparator. It knows that you have to move 5 meters, but actually you moved only 1 meter. The difference your brain is measuring, and that is giving command signal or control signal to your body. Your body is moving further. Yes, it moved to 2 meters. Then how much is the difference? 3 meters. So for 3 meters, again you have to move 1 more meter. In that way, our human body is acting like a automatic closed loop control system. Yeah. One more example I'll take. You want to go with 100 kilometers per hour on your bike. Take the example. You want to go with a speed of 100 kilometers per hour on your bike. What will you do? You start the bike and you accelerate, and you are going to look at the speedometer. If the speedometer is at 20, what will you do? You further increase. Why you are further increasing? Your brain is telling, brother, you want to go with 100, but present value of the speedometer is 20. How much is the difference is there? 80. You rise. Reach it to 60. Difference 40. Rise. Reach it to 80. Difference 20. Further rise. Reach it to 95. Difference is how much? 5. Further rise. Reach it to 105. Difference is -5. You have to decrease the acceleration. Why? Your desire is to go with 100 kilometers per hour. Means definitely you must take feedback. Means you must take the value of the output, actual value of the output, and you must compare that one with the desired output. According to the difference of those two, you have to work. Then only you are going to get accurate result. Without looking at speedometer, if you keep on accelerating, you may reach 100 or you may cross 100, but you are not going to stop the acceleration exactly at 100. Means you are not going to further accelerate or decelerate exactly at 100 if you are not measuring the output. Measuring the output, taking it for the purpose of comparison at the input, so that error will be produced. Control signal is going to depend on that error. This process is called as taking feedback. Taking what ma? Feedback. Very important, please. Taking feedback. I told you this point is called as takeoff point. This is actual output. This is also actual output. That is also actual output. Why it is, sir? Just we are measuring. We are not taking the value. See, mostly people will compare with electrical circuits like this, and they'll get confused. I'll try to reduce that what do you call confusion. Now, sir, 5 amperes is coming here. If there is one way here, 2 amperes is going like this, 3 amperes will go like this. This is valid only for electrical circuits, but here we are in control systems. Here, their current will divide. Here, signal we are measuring. We are not taking the signal, just we are measuring its value for the purpose of comparison. if it is 5 amperes, this is in circuits, please see, this is in circuits, okay, in circuits, it is okay, yes, but in control systems, suppose if this is some C of S, what is C of S? Laplace domain of output. Yes, see, if suppose if C of t is the output, C of S is the what? Laplace domain of output, or C of S is some function, whatever it is. Yes, if you take a takeoff here, what is this? This is also C of S. This is also C of S. Why, sir? We are taking the output? No, just we are measuring. You measure, somebody else measure, somebody else measure. The output remains C of S. So please do understand. Taking feedback means just comparing the value of output, actual output, with a desired output. Yes or not? This is called as a summing point. This is very, very important. Or comparator. Yeah, you can design a comparator by using operational amplifiers or BJTs. This is the input or desired output controller. This is a control signal. This is a actual output. Let me erase this 0. Okay. Please, this analysis is very, 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 very important. Very, very important. And one more thing I want to tell you here. What is the difference between open loop and closed loop control systems? What is the difference? Here, simply I want to write one point here. The control signal generated is going to depend on only input or desired output. I can write here only input or desired output. Very important what you called statement I'm going to write here. Yes, in the next pages I'm writing here. Come on. In open loop, yeah, let's take the heading open loop. Let's list out all the points here. Our heading is open loop control system. Open loop, yes, control system. Yeah, here let us take a closed loop control system. Yes, closed loop control system. The first point in open loop control system is what we understood. What is the drawback in open loop control system? Suppose if your brain is acting like open loop control system, human beings are not able to what you call to survive for no time. Within no time, human beings will die. Yes or not? Because for everything, our brain always act as a comparator, and it will give required signal, not more or not less. If you are taking more signal, accident will happen. Suppose you are in traveling, you are riding a bike. You know the example what we taken previously. Without looking at the speedometer, if you keep on rising, you may hit some object. Yes or not? So our human body, complete body, is an automatic closed loop control system. Closed loop control system. What is the first point in open loop control system? Control signal generated depends on only desired output. Only on desired output. Desired output is 5. Yeah, it keep on doing work without knowing whether it is reached 5 or not. No use. Yes or not? Yes. First point here is control signal generated depends only on yes, desired output. What is that, ma? Desired output. Yes, underline this desired output. Underline that desired output. Yes. Let us take the first point in this one, closed loop control system. First point in closed loop control system is what, ma? Control signal generated depends on the difference between desired output and actual output. Control signal generated, yes. Control signal generated depends on yes, desired depends on the difference between yes, difference between desired output, yes, desired output and actual output. Desired output and actual output. Yes, this is required for me. If it knows what is its desire, what is our desire, and what actually we reached, then that is going to be very easy task for us. It exactly stops there. Yes or not? Yes. Second point here is very less accurate, or accuracy is less. Here, in fact, I can say there is no guarantee of the accuracy. Less accurate. Here, more accuracy. Accuracy is more. Yes or not? Accuracy is more. Yes. Few more points are there. Here the point is. Which one is easy to design? In fact, open loop system is easy to design. It is easy to design. Yes. Simply you can understand. If that is easy, this is definitely complex in design. Yeah, what is the complex thing we are going to get? Taking the feedback, transducer, many things. We saw a very simple way of understanding this. Later in further stages, we are going to see many things. Okay, complex in design. Few more points are there. Let me list out those points, but justification of those points can be understood later in the later classes. Okay, see, whatever the point I'm saying, we will justify later. Definitely we are going to justify. Yes or not? I told you in the starting classes that advantages of S domain we are going to see later. Yes, we saw some advantages of S domain, that is Ohm's law, KVL, KCL directly can be written for images or elements in S domain. Yes or not? A difficult convolution in time domain will become simple multiplication in S domain. These things we already saw. Come on. Next point here is fourth point. That is this is less in cost. Somewhat it is expensive, I can say. It is expensive. Yes. More in cost. Why? Because a lot of care we have to take, a lot of other equipments are required to design this closed loop control system. Yes. Come on here. Next point is see, about stability, as we don't know what is a stable system. It is not appropriate to speak about stability here, but let me give few points whose explanation will be given later. If you are taking an open loop stable system, if you make it closed loop, there are chances that the system may be unstable. By keeping that point in mind, here more stable. Yes, more stable. What does it mean by stable system? We will understand in fourth chapter, or in the third chapter itself. We are going to give the introduction about stability. My point again, please do consider. Explanation for this point will be given in the later chapters. Okay, more stable. Yes, sir. Now the point here is observe. If you are taking an already open loop control system, if you are taking already a stable open loop control system, already a stable system it is, the same system if you make it closed loop, the same system what you take in if you make closed loop, there are chances of becoming unstable. I'm not saying always it is unstable, but stability definitely will be reduced. Yes. Lesser stable. But if you are taking an open loop unstable system, by applying a proper closed loop, we can make it stable. Please do remember, if you are taking an open loop stable system, if you make the same system into closed loop, there are chances of becoming unstable, or stability will be reduced. Okay, that is the first point about stability. If I am taking an open loop unstable system, by applying proper feedback, proper closed loop feedback, I can increase the stability. Proper, that's why I'm mentioning it proper. Okay, what does it mean by proper? We will understand later. This may not reduce the error, this will reduce the error. Those points we are going to see it later. If I write here, there is a possibility you'll get confused. So this is about open loop and closed loop control systems. There are a lot of points to discuss, but in the last of this chapter, or once we are done with stability, at that point of time, again this table I will be discussing. Very important in interview point of view. There are some few questions asked in the state government exams and ISRO DRDO exams for 1 mark, simple questions. But having good explanation, justification on these points, what I'm going to discuss is very important. As we are not done with the topic of stability, I'm not discussing the remaining points also here. Let us first complete about negative feedback and positive feedback. Yes. Now here we are done with the classification of open loop control system and closed loop control system. Which one is practically required for us? Open loop or closed loop? Open loop or closed loop? Closed loop control system. I forgot to discuss about the examples of open loop and closed loop. Let me write here examples of open loop and closed loop. What is the example of open loop and closed loop? Simple example what we discussed. Our practical elevator or lift is a closed loop control system. Elevator or lift. Yes, elevator or lift is the best example for closed loop control system. What is the example for open loop control system? Sorry, I have to take here. This is best example for closed loop control system is elevator. Yes, example is lift or elevator. Yes, elevator. What is the example for open loop control system, brother? Open loop control system, traffic signaling on roads. Yes, traffic signaling. Traffic signals. Sir, how traffic signal is an open loop control system? Irrespective of the density of traffic, for all 4 sides, it is going to allot the same amount of time. 1 minute, 1 minute, 1 minute, 1 minute. Yes or not? See, if it is closed loop control system, what will happen? More is the traffic, more should be the time given. Less is the traffic, less should be the time given. But in India, if you see any traffic lanes, automatic where you are finding automatic signals, there whether traffic is present or absent, the time given for one lane to pass is same when compared to other lanes. Yes or not? Yes. Traffic signals. Not only that, toaster, bread toaster. Yes. I think most of you might see toasters. Yes. If you see if you take a bread slice and keep that bread slice in toaster at just some time, 2 minutes or 3 minutes. After 2 minutes, whether it is baked or not, or whether it is properly baked or not, it is going to give it out. Yes or not? So bread toaster is an example for open loop control system. Many examples are there for closed loop control system. If you take anything, mostly that will come under closed loop control system. Best closed loop control system is human brain. Human brain. Yes or not? Many examples you can take for closed loop control system. So these are the examples for open loop and closed loop control systems. After this, we have to understand the mathematical or what do you call the control system point of representation of these things. Control system point of view representation of these things. Yes. One more point I want to clarify here, that there is an effect called loading effect. Loading effect. We'll see it later. Let me represent mathematically. Yes. Here, a system I'm taking here. Or let us discuss first loading effect. What is a loading effect? Let me discuss about loading effect. If that is done, we can play with all the functions, and we are going to define a new thing called transfer function, which is valid only in S domain. Okay, let me take a loading effect. Our heading is what? Loading effect. Very, very important. See, from this one we are going to develop a mathematical model. Okay, this system we are going to represent with help of a function in S domain. This controller we are going to represent with the help of a function in S domain. Both I'm going to multiply. Then people will get it out. For why you are multiplying both? Is it possible to multiply? Let us see. And in place of transducer, this transducer also we are going to represent with help of a function in S domain. Okay. So input in S domain, output in S domain, everything we are going to take up in S domain. Even this one also, system with a function in S domain, controller with help of a function in S domain, input in S domain, output in S domain. Everything we are going to discuss in S domain. But a few points we want to discuss before we start that one. That is a loading effect. Loading effect. The name itself says load. Load means what? For example, let us take a resistance as a load. Load is the one which is taking power, which is taking the power. Yes, come on here. I'll take one good example. A lot of confusions will be there to the students. All those confusions I will be eliminating here. Yes, very simple circuit I'm taking. Come on. Yeah. First point, load means if you take resistance only into consideration, as EC students are very less familiar with the inductive reactive power and capacitive reactive power and all those things. We are not going to discuss on all those things. Just I'm discussing only about resistor. Yes, resistance. More is the load. Means you have to remember one point that it is drawing more power. It is drawing what more power. Yes, I'm writing here a note point. Note. Load is high. First point is load is high means it draws more power, or it absorbs. In fact, instead of draws, we have to write it absorbs. It absorbs more power. First point. Second point, load is less. Vice versa. Load is less means, yes, it absorbs. Come on, man. Less power. It absorbs less power. These 2 points that we have to understand very carefully. Yes. Now we just discussed about load. Now we have to see about load resistance also. Let us see about load resistance also. Just in rough I'm doing. I have a voltage source of 10 volts. What is that, ma? 10 volts. I am connecting a load. Imagine you are connecting a load, that is bulb. Bulb load I will represent with help of resistance. Whose value of resistance is, suppose, say 1 ohm. How much is the power consumed by this one? Power consumed by 1 ohm is equal to V square by R. How much it is? 100 watts. V square, 10 square, how much? 100 by R, 1. Now, I am decreasing the load. Yes, decreasing the load. Let's write here V square by R1 I call. I am decreasing the load. Load is decreasing means it has to absorb less power. For the same voltage, for the power to decrease, resistance has to increase. Yes. Second one is I'm taking 10 ohms. Come on. How much is P 10 ohms? How much it is? V square by R2 or R10 we call. Come on. R10 ohms. How much is V square? 100 by 10. How much it is, ma? 10 watts. How much it is? 10 watts. Now if you see, one point you have to understand very carefully. More is the resistance, less is the power. Less is the resistance, I'll write here 10 square by 1. Less is the resistance, more is the power. Means load is high, load power is high, but load impedance is less. Come on, very carefully you have to understand. Load is high, load power is high. Load means power. Neither voltage nor current. Load means power. Load is high, load power is high. Power is high means impedance should be less, V square by R or V square by Z. Load impedance is high, load is less. See, load impedance is high. More is the impedance, less is the power. Power is less means low load or high load. Low is the load. That implies low load. Yes or not? Yes. Load and load impedance both are exactly opposite. If more is the load, less is the load impedance. If less is the load, more is the load impedance. Load means power. Please do understand. Load means what? Power. This is the clarity what you need. If you go to interview, they will ask some questions from this area. Why? Because many people don't know the terminology carefully. See, completely they understood in a wrong way. That's why they will do mistakes in interview and exams. Okay, come on here. This is more important for electrical students, in fact. Okay, come on. here. Load is high means it absorbs more power. Load is less means it absorbs less power. Third point, one more point I'm going to write here, that is load high means load impedance is load impedance is less and vice versa. Yes or not? Yes. If load is high, load impedance is less. If load is low, load impedance is high. So this is about those note points. Now come on here, because we are under the heading of loading effect. Come on here. I am taking this as 10 ohms. This as 10 ohms. Here I am connecting 10 volts. 10 volts. Tell me how much is the current that is flowing. This is the circuit which is existing previously. This is the circuit which is existing previously. Come on. Yes. Let's mark everything. Let us mark everything. What is the current that is flowing in this one? What is the current that is flowing in this one? Yes. 10 in series with 10. 20. 10 by 20. How much is the current that is flowing? 0.5 amperes. 0.5 is the amperes. What is the voltage that is dropped across this one? 5 volts. What is the voltage that is dropped across this one? 5 volts. Yes. Now, this is the circuit. Now, what we are doing is, we are connecting one more load to this one at these terminals. At these AB terminals, we are connecting one more impedance or resistance. Means that is called as loading. Either you increase the load or decrease the load. That is called as loading a circuit. See, loading a circuit means we are reducing the load or increasing the load. Now tell me, if I connect one more 10 ohms across this one, we are increasing the load or decreasing the load. 10 in parallel with 10 is how much? 10 in parallel with 10 is how much? 5. 5 plus 10 is how much? 15. What is the previous impedance seen by the source? 20 ohms. Now the impedance seen by the source is how much? 15 ohms. Impedance is reduced. Load is increased. Yes or not? We are increasing the load. So be careful with that. Now, if I ask some people, they will give answer in a very wrong way like this. If I ask what is the voltage across this 10 volts, they will say 5 volts. Sir, both are in parallel. Voltage will be 5. No. Why no, sir? This 5 volts, 0.5 amperes are the variables in the circuit when this 10 ohms resistance is absent. This black colored 10 ohms resistance is absent. At that point of time, this is 5 volts and 0.5 amperes. Why? Because the total impedance seen by the source at that point of time, it was 10 ohms. 20 ohms. According to the 10 by 20, the current is what? 0.5 amperes, 5 volts and 5 volts. Now, as soon as you connect this 10 ohms, what happened? The total impedance seen by the source is changed. Total impedance seen by the source is changed. Let me draw the same circuit in another page. Yes, let's take it in another page. Come on here. We'll understand very clearly. Yes, observe here. This is, yes, 10 volts. This is 10 ohms. This is 10 ohms. This is 5 volts. This is 5 volts. This current is 0.5 amperes. Yes, when another 10 ohms is absent, if I am connecting another 10 ohms, means I am increasing the load. Why? Because impedance is reduced. First, let's see what is the first case impedance seen by the source. How much it is? 20 ohms. Source means from source we have to observe like this. Yes or not? By closing the source. Yes, we have to see how much it is. 10 plus 10. 20 ohms are the impedance seen by the source. You have to stand in the place of source and see from this side. 10 in series with 10. How much it is? 20 ohms. Yes. Now, as soon as I connect another 10 ohm resistance here, what happened? The total impedance seen by the source is changed to 15 ohms. The current is no more 0.5 amperes. The current will be 10 by 15 amperes. 10 by 15 amperes. Now this voltage is no more 5 volts. That voltage is 10 by 15 into 10. Yes, this voltage is also no more 5 volts. So this is 10 by 15 into 10. 10 by 15 is the current. 10 ohms is the resistance. That is the voltage. Means as and when you connect an element, a new element into a circuit, all the previous voltages and currents will change. This effect is called as loading effect. This effect is called as what? Loading effect, or vice versa. Now imagine the first case is this 10, 10 and 10. These two are there and this is there. Then what is the voltage here? Voltage across this 10 ohms, 10 by 15 into 10. Yes. As soon as you remove this 10 ohms, impedance seen by the source will change, current will change, voltage also will change. What is the new voltage now? 5 volts. Without this means either you connect a new element into the circuit or you remove an existing element from the circuit, all the previous voltages, currents will change. That effect is called as loading effect. Loading effect. You might be thinking, sir, all of a sudden why we are discussing this loading effect? Then how to reduce this loading effect, or how not to happen this loading effect in a given circuit? Connect an amplifier, or not amplifier, exactly speaking, buffer. If you connect an ideal voltage buffer, loading effect will be zero. So what is that? Let's see. Here the point is, if you connect 10 ohms, what happened? Previous voltage was 5 volts. Now the voltage is changed to 10 by 15 into 10. The voltage is changed to 10 by 15 to 10. But I want, after connection of this one also, I want this 5 volts to remain as 5 volts. Even after connection of this 10 ohms. Does it happening here? No. It is changing or not? Yes, it is changing. Why? The load seen by the source, or the impedance seen by the source, is changing. Once impedance seen by the source is changing, current will change, voltage will change. That's why it is changed. But even after connecting this 10 ohms, I want the voltage across this 10 ohms to remain as 5 volts. The voltage across this 10 ohms to remain as 5 volts, and the current in the circuit to remain as 0.5 amperes. I want. How to do that? Let's see. Connect ideal voltage buffer. To avoid loading effect. Or note point, very important note point. To avoid loading effect. Buffer is used. Buffer is connected. How to connect that buffer? What is that buffer? We will see. In the previous circuit, we will take voltage buffer, ideal voltage buffer. First of all, let us see the characteristics of ideal voltage buffer. See, ideal voltage buffer. It is an electronic circuit. Voltage buffer. It is an electronic circuit. What is its design and all these things you learn in analog electronics. Ideal voltage buffer. How it looks. Ideal voltage buffer is like this. Ideal voltage buffer. Voltage gain is 1. Input impedance is infinity, and output impedance is 0. How to represent this one in the form of circuit? See, here, this is the input side you are connecting. Suppose if this voltage is VI. Now, how much we are going to get here? Here also we are going to get VI. Sir, why we represent it? I'll draw it once again. Yes, let us take a reference. This is 0 volt as a reference. Now, input impedance is infinity. Means I have to keep open here. Yes, this is the input side. Yes, same reference I'm taking both for input side and output side. Some people will misunderstand this diagram, how I drawn. Input impedance is infinite. What is this? Open circuit. Therefore, input impedance is infinite. Okay. Output impedance. Here I am taking the output. First of all, let's take the voltage as VI. This voltage is VI. And we are able to see that here input impedance is infinite because it is an open circuit. Let's take, yes, voltage gain is how much? 1. If voltage gain is 1, what is this one? A dependent current source. Dependent voltage source. Voltage dependent voltage source. Here this is VI. here I am going to get here AVI. How much is A? AV into VI. A is 1 into VI. What I got? VI as it is. We got VI as it is. Yes. So I am representing this one as VI. How much is the output impedance? 0. So output side I am representing with a short circuit. Yes. So this is the representation of ideal voltage buffer. You can try for ideal current buffer. With help of this, how loading effect can be reduced. Let me show with help of this. Come on. I'm taking the same previous circuit. Observe here. 10 ohms. Yes. 10 ohms. Yes. This is how much more? 10 volts. Yes. Now here, before I connect my load, let me connect ideal voltage buffer. Yes. Ideal. Yes, ma. Come on. Voltage buffer. Ideal voltage buffer. Now you connect the load. Now you connect the new load. What that is? 10 ohms. Now let's check. See, without this buffer and this 10 ohms, what are the voltage we got? This is 5 volts. This is 5 volts. Without this place, if you disconnect that completely, come on, you have to remember, or otherwise I will show you on board. Come on. Yes, here without this, what we have? 5 volts, 0.5 amperes. If you disconnect this one, we have, yes, I'll show that, but I won't connect. Yes, without this 10 ohms, what is the voltage? 5 volts and 0.5 amperes. But here we connected ideal voltage buffer and 10 ohms. Even after connecting this one also, we want this one to remain as 5 volts and 0.5 amperes. Let us see whether it worked or not. Let us see whether it is worked or not. Come on, let me draw it. This is 10 volts. Yes, this is 10 ohms. Yes, this is 10 ohms. Now come on, what I have to draw first? I have to draw ideal voltage buffer. Come on, brother. This is VI, open circuit. Input impedance is how much? Infinity. Yes. Here I have what? A voltage dependent voltage source. What is this value also? VI. How much is the output impedance? 0. What we connected here? 10 ohms. As this impedance is infinity in parallel with 10 is how much? 10. Infinity in parallel with 10 is equal to infinity into 10 by infinity plus 10. If you take infinite common, then you are going to get 10 as the answer. Exactly, you are going to get 10. Therefore, you see from here. Yes, sorry. We see from here. Come on. What is the input impedance seen by the source? Input impedance are seen by the source. If you see from here, this impedance is infinity. Infinity in parallel with 10 is how much? 10. 10 plus 10 is how much? 20. Then how much is the current? 0.5 amperes. How much is the voltage? 5 volts. How much is the voltage? 5 volts. This is 5. How much is VI? VI is 5. Therefore, this is also 5 volts. How much is the current in this one? 5 by 10 amperes. 0.5 amperes. In this way, we have to understand. Means the point, conclusion points I'm giving here. As and when a load is introduced or an existing load is disconnected from a given circuit, all the previous conditions of the circuits are going to change. Yes or not? If you want to avoid the loading effect, please connect a buffer. Even if you remove this 10 ohms load, then also it is 5 and 0.5. It is not going to change. Whether this 10 ohms is present or absent, that is not going to affect our previous circuit conditions. So we want to use buffer to avoid loading effect. So here you might be thinking, sir, why you discussed about this loading effect and buffer and all these things? Come on here. Very, very much important for me in control systems. Here I have a system like this. I have a system 1 I call it. Okay, or let me write it as its function directly. I have H1 of S. System 1 I am representing like that. Yes. Now we are giving input here. Input we call it as R of S. Input we call it as R of S. Output we are going to get as C of S. Output is C of S. Okay. Now, how many systems I have? Only one system. Let me represent here. System 1. System 1. What is C of S? Output is equal to, I told you, in time domain, it is the convolution of R of S with H1 of S. R of S with H1 of S, but in S domain, it is just a multiplication R of S into H1 of S. R of S into H1 of S. R of S into H1 of S. Now, what I will do is, I am going to introduce a new system in cascade to this system. A new system in cascade to this system. Not what I am doing is, that H1 I am taking as it is. H1 of S is as it is. Input is R of S. Input is R of S. What I am going to do is, I am going to connect a new system whose function is represented as H2 of S. Now I want the output. I call this one as C1 of S. C1 of S. I want C2 of S. Here, one thing we have to understand carefully. Yes, without this H2 of S, what is the output we have? Without this H2 of S connection, what is the output we have? R of S into H1 of S. Yes, multiplication of these two, R of S into H1 of S. As and when I am connecting this one, this output has to change or not? It will change. Why? Loading effect, brother. If you forget loading effect, it means you are not understanding the concepts in depth. Again, I am showing. Without this H2 of S, if this output is R of S into H1 of S, without this H2 of S, as and when I am connecting this H2 of S, definitely the output here has to change. Means, let me show again. Yes, I'll show. C1 of S. C1 of S is equal to what, ma? R of S into H1 of S. See, previously, without 10 ohms, we had 0.5 amperes, 5 volts and 5 volts. Yes, as and when we are introducing a new 10 ohms, what was happened? It is changed. Current became, yes, 10 by 15. Voltage, everything changed. Everything got changed. Here also, without this H2 of S, this is C1 of S. How much it is? R of S into H1 of S. But as and when I connect this H2 of S, this is no more. Yes, this is no more C1 of S, and C1 of S is not equal to R of S into H1 of S. If we take loading effect into consideration, but if I keep a buffer here, between these two, loading effect is nullified, and it is either with this H2 of S or without this H2 of S. C1 of S is going to be R of S into H1 of S. Yes or not? Yes. One very important note point here is, in control systems, loading effect is not taken into consideration. Why? Because it means we are not neglecting loading effect. We are not taking into consideration. Why? Because between every two systems, definitely there will be a buffer. Between these two, there is a buffer which we are not showing. Not required. Why? Because buffer is doing nothing. Just it is maintaining the same signal without this H2 and with this H2. Yes or not? So its gain is anyhow 1. Gain we seen previously, voltage gain of the buffer is 1. Okay, if you take a current buffer, ideal current buffer, current gain is going to be 1. So here this is C1 of S. C1 of S is equal to what, ma? R of S into H1 of S. Here the very important note point I'm going to give here. Note in control systems. Yes, in control systems. Yes, loading effect between the blocks, yes, is not considered. It means we are not neglecting. Yes, there is a buffer between these two blocks. There is a buffer. Now tell me, what is C2 of S? C2 of S is equal to what? C1 of S into what, ma? C1 of S into H2 of S. What is C1 of S? C1 of S is what? R of S into H1 of S into H2 of S. Means if two blocks connected in cascade, directly you can multiply in control systems. Yes or not? If two blocks are connected in cascade, directly those two blocks can be directly multiplied to get the output. Means these two systems separately, H1 and H2 are there. I can combine both into a single system. Yes or not? So this way we have to understand loading effect. Loading effect in control systems is not considered. So we are done with open loop and closed loop control system classification. We saw the advantages and disadvantages. There are some disadvantages of closed loop control system. One is stability, another one is cost and design complexity and all these things. Anyhow, once we are done with the topic of stability and error and all these things, at that point of time, again we'll make a good table to remember and to understand all the points carefully. Okay, here we need to develop a mathematical model for open loop control system and closed loop control system, and we are going to define a new thing called transfer function. What are the applications of transfer function? What are the not applications, limitations of transfer function? In fact, first of all, we have to see what is the use of transfer function. We have to see limitation means transfer function is applicable only in S domain. It is not applicable in time domain. It is applicable only for linear time invariant systems. It is applicable only with when initial conditions are zero. All these things we are going to take up in the upcoming sessions. So please do remember and understand these things. If you have any doubt at any point of time, feel free to ask me all the doubts. Okay, so it's your responsibility to prepare everything. All the points you must note down in class. All the points you must note down in class. Please solve the problems given by me, okay, in the form of CRQs, concept revision questions. Yes, so this is about open loop and closed loop control systems and loading effect.